All right, all right, all right. It is time for a new unit. This one will mostly be dealing with a little more algebra-y than usual. Talking about equations of lines, and we'll apply those to both geometry as well as our construction class. All right. So we're going to need a few formulas, a little refresher on some of these, all of which you have seen before. First off would be our slope formula. Usually, well, not usually, you'll see it written as m equals, and that is our change in y, so y2 minus y1 over x2 minus x1. And remember, when we're talking about these, we're talking about 2 points, so x1 comma y1 and x2 comma y2. And these could be any numbers for our points. It could be 3 comma 5 and negative 2 comma 6, and we can find the slope between those 2 points. All right, so that could be, this guy would be our x1, this would be our our y1, this would be our x2, and this would be our y2. All right, and that is a common notation that you'll see throughout many of these formulas. All right, midpoint formula. Midpoint formula is in a coordinate. All right, it's a coordinate form. So we're going to have our average of our x's, so x2 plus x1 over 2, comma, y2 plus, oops, I'm going to make that look more like a 2, y2 plus, I guess that's not much better, y1 over 2. Now, with this particular formula for midpoint formula, the order of the x's and the order of the y's doesn't really matter because it's addition, and addition is commutative. But you'll see it written with the x2 first, x1 second, y2 first, y1 second, because that's how most of the formulas are written. Moving on. We've got our distance formula. Our distance formula is, you'll see it as d equals the square root of x2 minus x1 squared plus, oops, I feel like I made that very complicated, plus, and then y2 minus y1 squared. All right, there we go. With this one, again, the order of your x's and y's, the order of the x's and the order of the y's, it really actually doesn't matter. Even though it is subtraction, think about what's happening. Our squared dealio is going to make whatever's in here positive. So whether I have, 5 minus 3, which is 2 squared, that's 4, or 3 minus 5, that's negative 2 squared, that's still 4. So the result is still going to be the same, but again, you'll see these formulas written with the x2 and the y2s first. All right, so those are like our main formulas. Now, moving on down here, slope-intercept form and point-slope form are forms for the equations of our lines. So for slope-intercept form, that is the most common one. That's the one that we're going to use all the time, y equals mx plus b. But you may also see point-slope form, y minus y1 equals m times x minus x1. All right, so what does everything mean here? Well, this is obviously our slope as referenced earlier, right? And then this guy here, that's our y-intercept. Hence the term, or the name slope-intercept, right? They make sense. That's crazy cool. All right. Our point-slope form. Why is it called that? Well, we've got our slope, right? And then you have your point. We'll use green for that. All right, so our point would be the x1 and the y1 as an ordered pair, right? So we'd have x1 comma y1, meaning it goes through that point and it has that particular slope. All right, cool. We really won't use point slope form that often, but it is a thing. It may come back up in Algebra 2 next year. We'll mainly use slope intercept form. Okay, if it doesn't otherwise specify, I guess you can really choose, but I'm always going to use slope intercept form, which is this guy right over here. Okay, y equals mx plus b. Most common. All right, time for a few examples. Write the equation of a line with a y-intercept of 7 and a slope of 2. So the y-intercept of 7, that's b, and the slope of 2, that's m. Remember our equation of our line, y equals mx plus b. All right, so I just got to plug those bad boys in. Y equals, slope is 2, x plus 7. Boom, done. And now you're going to be like, oh, is this all we're doing? This is easy. No, it gets more complicated, all right? But that's I feel like the common question that people will ask with the first example. All right. So now we have a little bit of different information. Write the equation of a line that passes through 4, -3 and has a slope of 1/2. So we still have our slope. And what I often like to do when these things start to get a little bit trickier is I say m equals 1/2. But I need to know b, because then it's easy to plug into y equals mx plus b. I've already got m. I need to find b. Well, how the heck do I do that? No, it's not just -3. That's the y coordinate of the point, okay? But we could use that point that is on the line to figure out what b is. So how the heck do we do that? All right, I got an idea because I've done this before. Alrighty, and so have you. So you might also have an idea. One of the most common ways of doing this, and I think my preferable method in doing this would have to be where I take my y. Oops, that is not a y. Y equals mx plus b, and I plug in what I know. Okay, I know that 4 is a point on the, or 4 -3 is a point on the line, so that's an x and a y value, right? That's what that ordered pair represents. It represents an x and a y. That's on the equation of the line. So that means I could plug in -3 for y. I could plug in 1/2 for my slope. I can plug in 4 for x. I'll pop that in parentheses. And I don't know what b is, okay? But look at that. I've got everything as numbers except for b. I can solve this. So -3 equals 1/2 times 4 is 2 plus b. Subtract the 2, I get -5 equals b. All right. So that means this guy's -5. And now do I have my equation of the line? Y equals 1/2 x minus 5. That would be my equation of this line. Okay? Our goal is always to get our slope and our y-intercept. Okay? This will come back up in Algebra 2, so you need to be comfortable with it. It will continue to come back. Getting an equation of a line will never, ever, ever go away. Okay? It's used all the time. Whew. Okay? Alrighty. Write the equation of a line that passes through the points 2, 1, and 1, -5. Well, how the heck am I going to do that? I don't have a slope, and I don't have a y-intercept. This is ridiculous. I don't have a slope, which is my m, and I don't even have a y-intercept, which is b. I feel like I have nothing. Ooh, but maybe I have something. If we remember, our slope formula is y2 minus y1 over x2 minus x1. It's our change in y over our change in x. So 2, 1 is my x1 and y1. And 1 -5 is my x2, y2. So, let's plug it in. I need to find my slope. I don't have a slope. Okay, let's do it. So, if my slope here would then be, I'd take y2, which is -5, minus y1, which is 1, over, and then I'd take x2, which is 1, over minus x1, which would be minus dose, and that gives me -6 over -1, which is equal to +6. So I'm going to write 6 over here for m. I've got my slope. Check. Okay, now how about my y-intercept? Well, this is now since we found the slope, is the exact same process as the last problem. I'm going to section this bad boy off, and now we're going to figure out our b. All right? I can pick either point right now to figure out what b is. So I have my y equals mx plus b. I could select the 2, 1 or the 1, -5. I'm going to pick 2, 1 because they're smaller numbers and not negative. Makes it easier to work with. So I have 1 equals, my slope is 6, my x is 2 from that point, plus b. So I decided to use this point when plugging it into this bad boy right here. So I have 1 equals 12 plus b. Subtracting, I get a -11 equals b. So b is -11. And when I want to write my final equation, I plug it all back in, leave the y and the x as is. I get 6x minus 11. Perfect. Awesome. All right. Uno mas and we're done. Alrighty, now a little bit more related to geometry. Given triangle ABC, write the equation of the median AM. Okay, well we have to recall first off, what the heck is a median? If you remember from a while back, a median is a line that is drawn from one vertex of the triangle, median. Let me actually, why don't I type this in? Alright, there we go, that's clear. Median is a line that's drawn from the vertex of a triangle to the midpoint of the opposite side. So you can actually have 3 medians in a triangle, right? I can draw from any vertex, it just has to be the midpoint of the opposite side. In this case, since it's labeled as AM, that was going to be circling that. There we go. Since it's labeled as AM, that means my vertex is A, and I'm going to the midpoint of the opposite side, this right here being M. Okay. Well, I know one point on the line is 3, 4, right? I'm going to jot that down. One point is 3, 4, but I don't know what the M is. I don't know what those coordinates are. Could I figure them out? Absolutely. Well, it says that it's drawn to the midpoint of the opposite side. So what do I need to figure out? I need to figure out my midpoint. So what are these coordinates going to be? Well, I would take, let's see here, C and B, right? Find the midpoint of that. So my midpoint is going to be 9 plus 3, so my x's over 2, comma, right? 9 and 3 are my 2 x's. And then 2 plus 0 over 2. So I'm going to get 12 divided by 2 is 6, comma, and then it's 2 divided by 2 is 1. So 6, comma, 1. Now, my goodness, isn't this just like the last problem? I am writing the equation of a line through 2 points. That's exactly right. It's just like an added step. All right, so what do I need to figure out first? Well, I need my slope and I need my y-intercept. Okay, so how do I figure out my slope? Got to use my slope formula. My slope formula is y2 minus y1, so we'll do 1 minus 4 over x2 minus x1. Cool. Alrighty, so that's -3 over 3, which is -1. Boom. Alright. Lovely. Let's continue. What do I need now? I need my y-intercept. Oh, how the heck am I going to figure that out? The same way I did before, right? Let's pick a point. I'm going to pick 3, 4, because that one's, I guess, it's the first one written down. I don't know. So I'm going to have 4 equals, right? Because I'm plugging this into my y equals mx plus b. I'll write that down just so we don't forget. Y equals mx plus b. Plug in 4 for y. And then I've got my m is -1. My x is 3 from that ordered pair plus b. All right. So I've got, let's see here, 4 equals, oops, -3 plus b. And then if I add 3 to the other side, I get b equals 7. All right. Cool. And that looks like I have everything I need, right? So I'm going to have y equals, right? X and y stay the same. Now I'm just popping in my slope, -1, or I can just put negative x plus 7. You could have -1x, or you could have -x plus 7. Either one would be just fine. Cool? Awesome. Well, that was a wonderful algebra review with a little tie-in of geometry at the very end. I'm sure you found very delightful. Quite delightful. Quite the delight, indeed. And just as a quick recap, children, really all these problems went back to the same thing. Find your slope, if you don't have it. Find your y-intercept, if it's not given to you. And then, bippity-bop, plug it back into the equation, right? First one gave us both, nice and easy. Next one, we had the slope, but had to find our y-intercept. Then we had to find both. And now we had to find both again, but a midpoint as well. But they all go back to basically being the same type of problem once you get the slope and the y-intercept. Woo! America, freedom, rock and roll, and Costco memberships.